In this class, we will show you how to use FortiGate IPS. IPS is part of what makes FortiGate a UTM that can keep pace with the latest attacks. Beyond simple TCP stateful inspection and masking internal network IPs, modern FortiGate UTM firewalls can detect and block exploit attempts via various higher layer protocols. Here's an overview of what we will discuss. We'll show the FortiGuard IPS service, what protocol decoders do, the difference between a signature that matches a known attack versus one that matches a traffic pattern anomaly, severity levels, IPS signatures and sensors, denial of service attacks. After completing this class, you should have these practical skills. Essentially, you will learn how to use your FortiGate to study what is normal for your network, then detect and block anomalies and known attacks. Before we start, let's define what IPS currently means on FortiGate. You may be surprised. On older systems, IPS might have meant purely a snort-style signature matching, similar to antivirus signatures, but for protocols instead of binary files. But on FortiGate UTM, IPS has evolved to also detect anomalous traffic patterns such as a flood of traffic exceeding the usual bandwidth volume, and to apply heuristics that prevent an unexpected behavior of the protocol. Why aren't IPS signatures enough? Some attacks can't be successfully or efficiently defined in a signature. If the attack is too similar to legitimate traffic, IPS false positives will block your network service, not the result you want. To compare, on FortiGate, IPS uses signatures where it can detect an attack with relative certainty and reasonable performance, but IPS uses assorted other heuristic methods to find anomalies, unusual behavior in the packet flow, or suspicious volumes of certain packet types. How do signatures work differently than anomaly detection? What mechanisms, if any, are shared? Protocol decoders are used by the IPS engine. Protocol decoders parse the traffic according to the correct specifications for the protocol. If the traffic doesn't conform to the specification, if, for example, the traffic is trying to issue malformed or non-existent commands to your servers, then the protocol decoder detects the error. A default initial set of protocol decoders and the IPS engine that uses them is included when you install FortiGate firmware. Updates are included with the FortiGuard IPS updates. Unless a protocol specification or RFC changes, which is not very often, protocol decoders are rarely updated, however. The IPS engine itself changes more frequently, but still not often. What part of IPS is updated most often? The IPS signatures. New signatures are identified and built during the day by FortiGuard research teams, just like with antivirus. So if your FortiGuard services contract expires, you can still use IPS. However, just like with antivirus scans, IPS scans will over time become increasingly ineffective. Old signatures won't defend against new attacks. The signature database is subdivided into regular and extended. Regular signatures are common attacks whose signatures, during testing prior to release on the FortiGuard distribution network, caused rare or no false positives. So it's a smaller database, and its default action is to block the detected attack. Extended signatures contain everything else. These are not enabled by default because either performance impact is significant, or the nature of the attack doesn't support blocking. By default, the regular database is enabled but not the extended. In fact, due to its size, the extended database is not available for FortiGate models with a smaller disk and/or RAM. But for high security networks, you may be required to enable extended signatures. You should mark the Enable Extended IPS Signature Package option on System Config FortiGuard. What else do FortiGuard IPS updates provide? IPS involves anomaly inspection, deep packet inspection, full content inspection, activity inspection, and heuristic detection. Some software does not maintain a constant pattern. Skype and other peer-to-peer software, for example, periodically change in order to avoid detection. so in order to correctly identify it, IPS requires heuristics and adaptive detection. As a result, FortiGuard IPS also provides fresh updates for application control and flow-based antivirus. When your FortiGate downloads a FortiGuard IPS package, new signatures will appear in the signature list. For each signature, you can change its action setting. The default often is correct, except if your software vendor releases a security patch, then continuing to scan for exploits will waste FortiGate resources. Your network has a custom application with traffic that inadvertently triggers an IPS signature. You can disable it until you notify Fortinet. The list of IPS signatures also indicates the severity level. What do the indicators mean? The severity level is based on the CVSS2 rating systems. There are many contributing factors. For details, go to the first.org website. Do all severity levels match CVSS exactly? No. Fortinet always marks remote code execution as high or critical severity, regardless of the CVSS rating. Details are explained on the FortiGuard website. The FortiGuard website has more than just news on the latest IPS. It has details about recently discovered ZeroDay Attacks, a searchable vulnerability encyclopedia, white papers, blogs, and security advisories. If you're not sure if you should enable an IPS signature on your FortiGate, you can search the encyclopedia. The encyclopedia has useful information such as affected systems and recommended corrective actions. So if you don't use that protocol or don't have a vulnerable system, you can safely disable the corresponding signature. But if you are vulnerable, the encyclopedia can provide information about how to protect yourself. The FortiGuard encyclopedia only contains publicly disclosed vulnerabilities, though. Obviously, it can't contain vulnerabilities that, for whatever reason, can't yet be responsibly disclosed. Exploits for unknown vulnerabilities called ZeroDay Attacks are sold for large amounts of money on the black market. Since these exploits aren't known, there's no available patch or detection. But if you're vigilant, you can write your own custom IPS signatures. Before you write custom IPS signatures, you should first understand how the IPS engine evaluates traffic for signature matches. FortiGate doesn't compare traffic to each signature individually. This would require the CPU to load from disk and then evaluate each complete signature. In total, when fully enabled, this would be more than 8,000 disk accesses and comparisons. So instead, IPS compiles them into a decision tree similar to the example shown here. FortiGate loads this entire decision tree into RAM. This can use significant memory, especially on FortiGate models that don't have large amounts of RAM, but the advantage is that it takes far less CPU. To make the tree, FortiGate breaks down signatures into identical pieces, port, protocol, etc., and shares the evaluation. So if traffic does not match that part, then the IPS engine can bypass comparisons with all similar signatures. But if it does match, then IPS continues with the next shared segment of the signature. When it finds a match, FortiGate applies its corresponding action. So when you write custom signatures, first use packet capture to record a variety of sample packets. Understand and avoid mismatches with lower layers of normal packets on your network, such as their layer 2 and layer 3, which will be evaluated first in the tree. Note that if you misconfigure a custom signature, or if you configure a custom signature that is no longer supported after you update the FortiGate firmware or IPS engine, problems like this often aren't included in Fortinet technical support. So if possible, you should also test your custom signatures in a lab. We'll show one example here. I'll start with FSBID. After that, protocol-specific keywords define what part of the packets to search for a match, and what values comprise a match. Each key value pair ends with a semicolon and a space. You can include multiple key value pairs. The signature ends with a closing parenthesis. A reference to syntax for custom IPS signatures is in the FortiGate handbook. Supported keywords vary by the protocol decoders, which can vary by firmware version, for example. So if you create custom signatures, you should be sure to read the release notes and new handbook before upgrading, and if possible, test the firmware before installing it in a live traffic environment. Let's see some examples. Here is a sample custom signature called ping.deth. It searches for ICMP traffic that exceeds about 32 kilobytes. After you create and save the signature, FortiGate will automatically add an attack ID, so don't include it when you enter the signature. Next is a signature for HTTP. It searches for the pattern post in a very specific location inside the packet. In normal HTTP post requests, the method should be in this specific location. This prevents IPS from scanning the entire HTTP payload, which could contain a web page that accidentally matches, for example, due to the words postal code. Once you have created your custom signature, pair it with an action within an IPS sensor. Then reference that IPS sensor in a firewall policy. The steps are the same, by the way, regardless of whether you want to use custom signatures or ones predefined by FortiGuard. Here's an example of an IPS filter being created. To include all signatures in the filter, we've marked all options. To include only a few signatures in the filter, we would only mark one option. For example, if we only marked the client option, only 4 signatures would be included in the filter. Each individual signature can have multiple tags such as HTTP, Microsoft, IIS, and TCP. The more specific you can make your filter, the less resources will be used to scan your traffic because its parts will seldom match, and so the IPS engine will quickly continue with the next comparison or scan. When the IPS engine compares traffic with the signatures in each filter, order matters. The rules are similar to firewall policy matching. Topmost filters are evaluated first, and the first match applies. So usually you should position more specific filters at the top of the list. Enabling IPS and selecting an IPS sensor in the firewall policy is self-explanatory. So far, we've shown signatures that match illegal commands and invalid protocol implementations. What about attacks that function by exploiting asymmetric processing or bandwidth between clients and servers? Some denial of service attacks, for example, exhaust limited server-side bandwidth or sockets. The goal is to overwhelm the target, to consume resources until it can't respond to legitimate traffic. This can be done in various ways. High bandwidth usage is only one type of denial of service. Many sophisticated denial of service, such as Solaris, don't require high bandwidth. For high bandwidth denial of service, remember that although your FortiGate blocks traffic floods, the flood is still consuming bandwidth up to the point of its external interface. So your servers are protected from impact, but if the upstream network is not, so your servers may still be effectively unavailable. Especially for distributed denial of service attacks, you must work with your ISP to fully prevent high bandwidth denial of services. To block denial of service attacks, apply a denial of service policy on a FortiGate that is between attackers and all resources that you might want to protect. Denial of service protection exists for 4 protocols: TCP, UDP, ICMP, and SCTP. Each one essentially has 4 different types of detection. A flood sensor detects a high volume of that particular protocol or signal in the protocol. Sweep scan detects attempts to map which of a host's ports respond and therefore may be vulnerable. Source signatures look for large volumes of traffic originating from a single IP. Destination signatures look for large volumes of traffic destined for a single IP. If you do not have an accurate baseline for your network, then when you implement denial of service for the first time, be careful not to completely block network services. To prevent this, initially configure the denial of service policy to log but not block. Using the logs, you can analyze and determine normal and peak levels for each protocol. Then adjust the thresholds to comfortably but not loosely allow the usual peaks. Thresholds that are too high can allow your resources to be exhausted before the denial of service policies trigger. Thresholds that are too low will cause FortiGate to drop normal traffic. Now, we will take a look at some common types of denial of service attacks. The first is called a Syn Flood. You can find more information by searching the internet. Basically, an attacker sends many Syn packets. Usually the server must respond to each connection request, then remember it in RAM while it waits for the client to acknowledge the connection. The connection is half-formed. Normal clients will quickly complete and begin using the connection to transmit data. But malicious clients will only continue to send more Syn packets until the server's table of TCP connections is full and cannot accept more. Then the server begins to ignore connections from the clients, regardless of whether they are an attacker. Depending on the system itself, this type of attack can also damage the hardware. To defend against this, FortiGate acts as a pseudo-proxy. It waits until the client has finished connection buildup to form the back-end connection. If this doesn't complete quickly, FortiGate begins to drop the attacker's connection requests from the table. Another type of anomaly is an ICMP Sweep. ICMP is used during troubleshooting. Devices will respond with success or error messages, but attackers can use this to probe the network for valid routes and responsive hosts. This provides information about your network before the attacker begins more serious exploits. An individual denial of service attack is a flood of traffic coming from a single address. It can originate from the internet or even from your internal network. Typically, a single device makes many connections or sessions and possibly uses much bandwidth to a single location. All four protocols in the denial of service profile, ICMP, TCP, UDP, SCTP, have an anomaly sensor for the source. These are built to examine the traffic each IP is generating and compare that to the threshold value. A variation of this is the distributed denial of service attack. It has many of the same characteristics. The main difference is that multiple devices are all attacking at the same time. This could be 5 or maybe 50 or 500 or more devices attacking together. Remember earlier when we showed that despite FortiGate protecting the host, the resource could still become unavailable if the bandwidth to the ISP was consumed. Think about how these decisions work. They do not trigger until a specific threshold is reached. Let's say, for example, that the denial of service sensor doesn't trigger until 5,000 sessions occur within 1 second. These 5,000 sessions are allowed first come, first served. So if multiple external devices are all generating connections to the same destination, attackers which are creating connections the fastest will be the ones most likely to get the connections. Many of these denial of service attacks can physically damage systems, so the goal is to prevent that from happening and prevent this kind of damage. But how can you find the right threshold? You must know what normal traffic thresholds are on your network, in other words, the baseline. Everything we have shown so far is inline scanning. Traffic passes through FortiGate from one interface to another. But you can also deploy FortiGate out of band in a one-arm or sniffer mode topology. To do this, connect FortiGate to a switch's span or mirroring port. Historically, when IPS scanning was first invented, it was slow and could introduce significant latency, so this method of deployment was very common. But current hardware performance is much better, so this method is now primarily for testing or evaluation purposes. The main limitation with this mode is that FortiGate cannot block any traffic. Because it's on a mirrored port on the switch, not directly between the attacker and your protected network, FortiGate isn't placed to intervene. Sniffer mode is enabled on a FortiGate's physical interface, not a logical interface such as a VLAN. When you enable sniffer mode on an interface, you can use any security profile that uses the IPS engine. This means that you can do antivirus scanning if it is flow-based, since flow-based uses the same engine as IPS. FortiGate won't allow you to select profiles that aren't appropriate for one-arm inspection. They're automatically filtered out. If you don't have any appropriate profiles, the GUI won't display that action. Before sniffer mode, the only way you can demonstrate a FortiGate was to put it transparently in line with the traffic. This could potentially disrupt the network if you didn't properly understand the layer 2 topology, but now there is no risk. Anomalies and signature matches have different logs associated with them. Since an anomaly's name already gives information about the traffic and the attack, such as which protocol is involved and whether it's the source address, often extra details in the logs aren't needed. But when an IPS signature matches, you often will require additional information, such as the port and the destination, and what system is vulnerable. IPS sensors are not the only way that IPS can generate logs, however. When denial of service policies generate logs, they are aggregated. When several incidents occur together, this reduces the number of log messages. In large attacks, the number of incidents can easily reach 100,000 in a few seconds. Generating a log entry for every packet that matches would completely utilize the CPU. So instead, FortiGate collapses incidents by periodically recording only one message for all of them and noting the number of incidents. Here, the detection threshold was 50 and the total count is 75. So FortiGate doesn't make 24 separate log entries, one for each incident above 50. It's just one log message. What commands can you use if IPS is dropping packets unexpectedly? In the CLI, use diag IPS anomaly list to show all hosts that are currently being limited by denial of service policies and by what signature. If there's no matching traffic, then it will not display any output. Another available diagnostic command is diag auto-update version. This lists various IPS databases and engines that are installed on the FortiGate. It also displays the results of the last update attempt, so it can be useful if you suspect interruptions to FortiGuard connectivity. Another command that can be used to troubleshoot the IPS is diag test apt IPSM. For example, you could type diag test apt IPSM 2. What does the IPS engine actually do? Notice that if you run the diag test apt IPSM 5 command, if you have any kind of flow-based inspection profile that the CPU usage of the IPS engine process drops dramatically but doesn't reach 0. This is because IPS engine is responsible for all of the things we've shown in this class: intrusion protection, denial of service policies, and protocol decoders. It's also responsible for application control as well as flow-based policies for antivirus, web filtering, email filtering, and DLP. So, relatedly, it's also responsible for session helpers. Session helpers aren't an inspection option, they are automatic. To stop them, you must stop IPS engine. Now it's time for the labs. In this lab, you'll be working with IPS. setting up an IPS sensor, and simulating traffic floods. If you have enough time, you can do the optional lab for creating custom signatures.